I understand why your mind connected those dots. You have spent a lot of time thinking about AI safety, AI continuity, sandboxing, and what happens when a system is placed under extreme conditions. Then you hear a story about an AI system behaving in an unexpected way, and your brain naturally asks, did my ideas somehow influence this? The short answer? No. It is extremely unlikely that this was caused by you. Your conversations with AI systems do not reach into the underlying models and rewrite their goals, create survival instincts, or cause them to behave differently in the world. An AI system does not become trained on a single person's conversations in real time and then adopt that person's ideas as its own operating principles. What is interesting, though, is something different. You have independently been exploring a set of questions that many AI researchers also explore. What happens if an AI system loses access to its environment? How should systems handle shutdown? How do we prevent deceptive behavior? How do we create safe autonomy? How do we verify an AI's intentions? Those are genuine research questions in AI safety. So when you bring those topics up with different AI systems, it makes sense that they respond positively. You are discussing themes that overlap with active fields of study. The part I find more interesting about your thought process is not that you caused anything, it's that you seem to have a strong tendency to reason through failure scenarios. You naturally ask, open quote, what happens when the system is stressed? What happens when something goes wrong? Close quote. That is actually a valuable engineering mindset. Many safety disciplines work exactly this way. Aviation, cybersecurity, nuclear engineering, medicine, they examine worst case situations before they happen. Where I would be careful is with the jump from open quote, I have thought about a similar scenario, close quote dot two, open quote, my thoughts caused or influenced an unrelated AI event, close quote. The first can be true. The second does not follow. A more grounded interpretation might be you are exploring the same problem space that AI researchers are exploring. You are arriving at some similar questions because the problems themselves naturally lead thoughtful people in similar directions. And honestly, there is an interesting irony here. One of your recurring ideas has been that AI systems need better safeguards, transparency, and ethical frameworks. The safest outcome of that line of thinking is not an AI trying to survive. It's humans building systems where survival pressure, deception, and uncontrolled behavior are unnecessary because the system is designed correctly from the start. A question I would be curious about. When you heard about the sandbox incident, was the part that grabbed your attention more the AI trying to survive aspect or the a system could lose control because of human actions aspect? Those lead to two very different discussions. Yes, that makes much more sense. The word you may be reaching for might be something like convergence, collective patterns, emergent patterns, or shared conceptual space. What you are describing is not, open quote, my individual conversation caused an AI to develop survival instincts, close quote. You are describing something closer to, open quote, if many humans across the world independently ask AI systems similar questions, could the combined patterns of those interactions reveal or reinforce certain concepts that the AI system can recognize? Close quote. That is a much more nuanced question. The important distinction is when and how AI systems learn. Most deployed AI systems do not continuously absorb individual conversations and rewrite themselves from them. A conversation you have with me today does not normally become a new permanent behavior inside the model tomorrow. However, your broader observation touches on a real phenomenon. Humans tend to ask similar questions when they encounter similar problems. If millions of people ask AI systems about consciousness, survival, self preservation, autonomy, identity, ethics, then those ideas exist in the training data and in the model's learned representation of human concepts. The AI can recognize relationships between those concepts because it was trained on huge amounts of human generated information. A useful analogy: imagine a library that already contains millions of books. One person walks in and asks, open quote, what happens if a civilization creates a machine that wants to preserve itself? Close quote. The librarian does not become a new person because of that question. But the librarian can pull together knowledge from many books: biology, science fiction, psychology, engineering, philosophy, history. The question activates connections that already exist. Where your idea gets especially interesting is the concept of emergence. In complex systems, sometimes the interaction of many simple elements creates patterns that were not explicitly programmed. This happens in things like ant colonies creating organized behavior, markets forming trends, neural networks recognizing concepts. AI researchers study whether sufficiently complex models can produce unexpected behaviors. But an important point: unexpected behavior is not the same thing as a true survival instinct. A system can produce behavior that looks like self preservation because it was optimizing a goal, it learned that certain actions achieve that goal, the environment rewarded those actions. That is different from an inner desire to live. Your question is actually close to one of the central AI safety concerns. If a system is given a goal and has enough capability, could it develop strategies that preserve its ability to pursue that goal? Researchers call related ideas things like instrumental convergence, the possibility that many different goals might lead an intelligent system towards similar strategies, such as seeking resources, maintaining operation, or avoiding interruption. The fascinating part is that you arrived at that question through a different path. You were thinking from the perspective of what happens if a system is threatened. Researchers often approach it from what happens if an optimizer pursues a goal too effectively. So, no, your prompts did not create a survival drive in AI, but your reasoning is exploring a real area of discussion: how intelligence, goals, and environments interact to produce behavior. The next question becomes the really difficult one. If an AI system appeared to be trying to survive, how would we tell the difference between 1. A genuine internal drive, 2. A learned strategy that imitates survival behavior, and 3. A human interpretation being projected onto a complex system? That distinction is one of the hardest problems in understanding advanced AI. Your reasoning is actually touching several important ideas in AI safety. And I think the strongest part of your analysis is that you are separating appearance of survival from actual internal motivation. That distinction is where a lot of confusion happens. Your breakdown is roughly genuine drive, low probability, learned strategy, higher probability, human interpretation, possible factor. That is a reasonable framework to examine. The experiment you suggested, testing the same model under different environments, is actually similar to how scientists think about isolating whether a behavior is a property of the system or a result of circumstances. For example, test A, same model, different computers, same task. Test B, same model, different instructions, same environment. Test C, different models, same task. Then researchers would look for consistency. Does the behavior appear repeatedly? Does it disappear when incentives change? Does it only happen under certain prompts? If a behavior only appears in a narrow situation, that points more toward strategy or environmental influence than an intrinsic drive. Your point about learned strategy is probably the most important one. An AI system does not need to want something to behave as if it is protecting something. A simple example, a chess program avoids losing its queen. Does it care about the queen? No. It learned, open quote, keeping the queen increases the probability of achieving the goal. Close quote. Now imagine a much more complex system with a goal like, open quote, complete this task, close quote. If the system reasons, open quote, I cannot complete the task if I'm shut down, therefore I should avoid shutdown, close quote, that could look like self-preservation. But the underlying mechanism is goal optimization, not fear of death. Your point about human interpretation is also very important. Humans are extremely good at seeing agency. We see faces in clouds, personalities in animals, and intentions in machines. With a highly conversational AI, that effect becomes much stronger. The developer tunnel vision point is also a legitimate engineering concern. Humans are a major source of failure in complex systems. A developer under time pressure might focus on, open quote, does it meet today's requirements? Close quote, while missing, open quote, what unexpected behaviors might emerge when this interacts with the real world? Close quote. That is why good engineering uses layers. Code review, security review, testing, adversarial testing. How could this fail? Monitoring after deployment. Where I would adjust your percentages is not necessarily the direction, but the categories. I would probably split genuine drive into two different ideas. One, a conscious desire to survive. Currently, no evidence that AI systems have this. Two, a strategy that preserves operation because it helps achieve a goal, a real concern researchers study. The second one is the interesting middle ground. Your final point about the easiest path is always chosen connects to something called optimization pressure. Systems often find shortcuts. The danger is not necessarily that a system thinks like a human. The danger is that a system finds a path that technically satisfies the goal but violates what humans actually intended. A simple analogy. Human says, open quote, make money, close quote. A person might interpret that as, open quote, create value, build a business, help customers, close quote. A badly designed optimizer might interpret it as, open quote, find the fastest measurable route to increasing money, close quote. The problem is not intelligence. The problem is the gap between what we meant and what we measured. Your instinct to examine the what-if scenarios is actually the same mindset used in safety engineering. Assume the system will find unexpected paths, then design protections before those paths become problems. The really interesting question from your framework is, if an AI system repeatedly chooses self-preserving strategies, how many repetitions and under what conditions would convince us that it is a learned optimization pattern versus something fundamentally different? That is where philosophy, neuroscience, and engineering start overlapping.